Welcome, everyone. My name is Clint Armitstead. I'm the sales manager for North, Central, and South America here at Isograph. Today, first of all, we want to thank you for joining us. And just as a quick introduction, Isograph has been creating and improving engineering software for over 32 years now. Our headquarters is based in the UK, and we have a beautiful office here on the fringe of what's called Silicon Slopes here in Alpine, Utah. I'd like to introduce today our presenter, Joe Beland. He will be conducting our presentation. He is our lead technical support based here in the UK. Joe has been with Isograph for over 16 years and has worked with thousands of organizations, helping their employees become conversant with our software tools. Today, Joe will be presenting a high-level overview of our latest release of Reliability Workbench and how that dovetails so nicely with ISO 26262. And so without any further ado, I'll shortly be turning the time over to him, but if you have interest in our products and modules or would like to learn more about our software, you can visit isograph.com. We also offer a free demo of our software, so please take advantage of that. It's without obligation. There's no credit card required. Please check that out. So with that said, Joe, if you would like to take control and dazzle us with all of the neat new features of Reliability Workbench and ISO 26262 features, we would love to have you proceed.
Sure thing, Clint. Firstly, can you see my screen? I've shared it, so hopefully you can see it all.
I can see it.
Okay, yeah. So let's talk about the Reliability Workbench and the improvements that we've made over the last, actually, several versions. Firstly, version 14.0.1 was released last week. And over the last few versions, even before that, we've been implementing some new features to the tool to assist with the ISO 26262 style automotive analysis that must be done on various systems, and how to get the results that you're always looking for, the metrics, random hardware failures, all those different metrics that you'd be looking at. So firstly, we'll start in the Reliability Workbench. We'll start in the FAMICA module. We're going to use that same downwards look through the modules. The ones that I'm going to be highlighting today are the FAMICA, the Fault Tree, and the Safety Assessment module. So those are the three most commonly used in association with 26262. Oh, and I should also mention the prediction is also used as well in those arenas. But I'm focusing on these other three. So firstly, the FAMICA, a couple versions back, we had a big update with the FMEDA, Failure Modes Effects and Diagnostic Analysis, that was done in the FAMICA. At first, we made it conform closer to IEC 61508, which is sort of the parent standard of a number of specific industry standards, ISO 26262 being one of them. And then recently, we've added a bunch of new ISO 26262 calculations. So let's take a look at what those new features within the FAMICA module represent. Firstly, most of the FAMICA works as normal, as it did in previous versions. We have a hierarchy for our components. Now, of course, in traditional FAMICAs, this can be either a hardware or a functional style FMEA. This one here is a hardware FMEA. I'm listing individual devices, relays, capacitors, transistors, various different components, integrated circuits, etc. And then their failure modes. And now that's so far like every other FAMICA in existence. Now what we've done in this latest version is we've added the ability for each one of the failure modes for each one of the devices. So again, this is one of the devices. And down here in the grid, it shows my failure modes. They also show up here. For each one of these failure modes, if I double-click to reveal the dialog to get the failure mode dialog, we've added a new ISO 26262 tab. And what this allows us to do is enter those probabilities, those percentages, as broken down in, I think it's in section 10 of ISO 26262. Basically gives a little bit of a flow chart in that section. You start with your device and you ask various questions about it. Are the faults safety related? If so, what percentage of the, if what percentage of the faults are safe failures, of those not safe failures, what percentage violate the safety goal, do you have a safety mechanism in place, what percentage are prevented by the safety mechanism, and then on the multi-point faults, of those remaining multi-point faults, what percentage are detected and perceived. So you can enter the values that you would normally use in that spreadsheet in ISO 26262. And of course, what the tool can use this to do, and I'll get to it and show the results in a little bit, but it can use this to get those calculations, because in the standard it will then give, based off that breakdown, failure rates, like your single point fault failure rates, your multi-points, your residual faults, and various metrics like that. So we can use this information to calculate those results. I'll point out the new feature in Reliability Workbench 1401 from last week is we now allow you to specify the different safety mechanisms. Now, so this example file I have not updated to the latest version, but before it just used to be you check a box and say this is a safety mechanism, but now you can track the safety mechanisms and figure out which faults are prevented by which safety mechanisms. So overall you can see for each safety mechanism what sort of percentage of faults it prevents. Okay. So that's the new thing, and unfortunately I don't have it set up in this file to show how it's used. Okay, so what I would go through then is with my FAMICA. I do my standard FAMICA, entering all that information for each block. And of course with a standard FAMICA, the block failure rates is entered. So I'm using FITS, or failures per billion hours, as my unit. The block failure rate is entered here. That's decomposed based off of the alpha, the apportionment, which tells what percentage of the faults of the block are due to that specific failure mode. And that's, again, standard to all FAMICA variants. And then we break in and start using those ISO 26262 calculations about safe failure percentages. Okay, so we can enter that for each individual failure mode for each individual block. And then what the software can do, so now that it has all that information, it can roll it all up. Basically, many of our clients have to build a complicated Excel spreadsheet to do all this. Now it's directly integrated into Reliability Workbench, where it's all rolled up, and in the results summary, we've added a new ISO 26262 tab, where it gives the roll-up of all those results. My not safety related, so firstly this is my failure rates, again, in failures per billion hours. My not safety related faults, my safety related, my single point fault metric, residual faults, multi-points, detected, perceived, and latent. And then finally, this is what many people are after, the single point fault metric and the latent fault metric. Okay. This information can also be presented much more clearly. You probably wouldn't want to take a screenshot of this and include it in your certification documents to send to your, to your clients. So we've also included reports, built-in reports. These come with Reliability Workbench, that we're trying to mimic the look of the reports from, or the tables from ISO 26262. So again, it's the same thing, listing all of my components, their failure modes, and then for each one, listing the residual or single point fault failure rates and the latent multi-point fault failure rates for each failure mode. And if I scroll all the way to the very bottom, you can see it's giving me the total sum for those two columns, giving me my overall single point faults plus residual fault metric, which again is going to give me my my PMFH, the probability metric for random hardware faults, PMHF I should say, probability metric for random hardware faults. Okay. So again, this is really sort of the ultimate goal that many people are after when they're doing their 26262 analysis. Okay. Clint, do we have any questions so far?
No, this is great. Keep going.
Sure, okay. So that's firstly the FAMICA module. Now, FAMICA is great, and it does all these calculations. We can do them exactly as they are in the standard, but there are limitations to FAMICA methodologies. Of course, this isn't just Reliability Workbench. This is just the way FAMICAs work, the way the methodologies work. There's limitations primarily in the types of logical considerations they can handle. There isn't really much in the way of redundancy calculation. I mean, granted, there is a checkbox where I can say there's a safety mechanism in place, but I can't say, for instance, one relay is redundant to another relay. I can't specify voting arrangements, that there's a 2 out of 3 voting arrangement between some of these components. I can't model complicated logical relationships of the devices and components in the system that some more complex systems require. That's where we step into the world of fault tree analysis. So let me pull up another example file, this time with a fault tree. So again, with fault tree analysis, now there isn't anything particularly new within the most recent version to do these 26262 style analyses. We just do them the same way that's essentially we've been doing them for quite a while. Build the fault tree to take into account that more complicated analysis. So we have our top-level hazard, and then we have our different contributors to that top-level hazard: a CPU failure, volatile memory failure, the failures which can cause the hazard, safety mechanism failures, broken down in a traditional fault tree method to the individual component faults. So the basic events representing those component faults which can contribute to that hazard. Now it's a little bit trickier to get those single point fault metrics. So single point fault metrics would be you calculate things such as the number of the failure rate of the first order cut sets in the fault tree. So that might involve looking at the result summary, looking at the cut sets for the fault tree. You can try and look for things such as first order cut sets to try and find single point fault metrics. And of course, these can be, you can create custom reports to help find these things. I've been working with some of my colleagues in recent days to simplify this procedure with custom reports and the like to generate the single point fault metric, residual fault metrics, and PMHF as well. So again, we can also break into those standard fault tree methods to analyze the system, and that would give us a better ability to model the complicated system logic and how everything interacts with everything else. Now, since there aren't any specifically new targeted features for 26262, I'm not going to go into too much detail on the fault tree. Again, I think we have several other videos and things you can watch if you're interested more generally on how fault tree analysis works. What I do want
hey, Joe,
if
I can just interject real quick. I think the point that you're making is really important, that our customers and our users drive a lot of the reporting capabilities and some of the structure of our software. Mm-hmm. And so, I mean, ISO 26262 is evolving, and we're evolving with it. And so I really appreciate you mentioning your contribution in making some of this information that automotive specifically is looking for. Sure. But yeah, I mean, we make a big effort to make changes to the software, and it's the feedback from our users who help us develop a lot of these changes. Anyway, that's my 2 cents. I just wanted to add real quickly.
Yeah, right. Absolutely. Yeah. So again, we've been looking into what changes and things that can be made to sort of assist with this. Because again, those calculations, the Section 10 calculations for 26262, are they've been described to me as sort of a shortcut, like taking a failure rate, a safe or an unsafe failure rate, and multiplying it by the failure percentage, the probability of failure percentage for a safety mechanism. That's kind of a shortcut calculation. Fault trees are inherently more complicated than that. So there's a little bit of translation that has to be done. This is where it gets a little more complicated with using a fault tree to calculate these hardware fault metrics. But it can be done, and maybe there's a quick look at how we could do that. The basic events themselves is where we'd enter the failure information, the failure rate. So generally, each basic event would represent that specific failure mode. So rather than entering all that information, the failure rate, the prevention by a safety mechanism, all that into one spreadsheet, essentially that's going to be different events within the fault tree. You're going to have events for the component faults. You're going to have events representing the safety mechanism faults, and the fault tree logic, calculation logic, kind of takes over that. And so eventually, what you're going to get at the top level for the fault tree, right now it's showing a Q value. We're probably interested in more of the failure frequency. What we ultimately want is the probabilimetric for random hardware faults, and that's what the top event value is essentially going to give us once we've constructed our fault tree. The point is, with a fault tree, we're more focused on the construction logic we need to capture the values that we want to get the probability metric for random hardware faults. Again, it's going to be based on component faults and safety mechanism. That really how we arrive at depends more on how we construct the fault tree, how we logically arrange our events with each other, rather than on what numbers we type in to the basic events. So I just wanted to put that out. There's a lot more. I think I would say it's on the user to construct the fault tree in a way that gets the answer thereafter, and that's just inherent to fault trees, generally speaking. You always have to build them in a specific way to calculate the result you're after. Okay. Does that make sense, Clint?
Yeah, that's great. I appreciate that.
Sure. Okay, but what I do want to highlight with the fault trees, so again, these fault trees are often used with the 26262. What I do want to highlight is the new features can be used in conjunction with the fault trees with the System Safety Assessment module. The System Safety Assessment is a module we added a few releases ago, and it caught on widely with aerospace. They've been our big drivers of development so far, and then also with the latest version, automotive as well. We've added it in new 26262 style calculations. The way the safety assessment module works is it's often done to do, say, like an FHA or a verification. It's designed to work with traceability. Whenever you have a requirement, so here's where the fault tree can tell you if you're meeting a requirement, but now we want to have some way of tracking our requirements, showing we've done our verifications, and showing that we're meeting those requirements. And that's what the safety assessment module is focused on. Now I've built something just very, very simple right here, just to highlight the basics of how it works. Here we have our automotive system, brake system. We list its functions. Now here I've listed one function, stop the vehicle. Of course, you're going to have more complexity to it than that. I'm keeping it simple for this overview. And then the functional failure. So the functional failure would be fails to stop the vehicle. And that's what we want to investigate. We're going to have requirements for that failure. It shouldn't happen more than X amount of time. Essentially, what we're going to have is our ASIL levels, our automotive safety integrity levels. So I can open that up, and the way I handle that in the new version of the safety assessment modules, I can define requirements. So I've had it defined a requirement for my top-level hazard probability, and for that I can set decomposed ASIL levels. So I can choose from A, B, C, D, or QM. The DAL, by the way, from my experience, is usually used more commonly with aerospace, the development assurance level. It's kind of a different way of getting at the same thing. We have different levels to rank the requirements. So something that's a critical will be ranked a higher, like a level A. Something that's not so bad, in DAL will be ranked level E. So again, so automotive, we have the same options from QM through level A through level D. So we can rank how bad or how lenient we can be with that safety consideration. So this one actually might be level D. I can't remember how automotive, I think, does it backwards, where D is the highest and A is the lowest. Most other places are the opposite, where A is the highest and D is the lowest. Okay. So we can assign that ASIL level, and that can come then with some requirements verification. And we can use this to verify. Oops, I wanted to go back here. We can link it to the fault tree gate, which is what I've done here. Link the probability verification for the fault tree. And we can use this to track. So I haven't set a requirements for this top-level hazard probability. But we can use this to link it to the fault tree now. So it's, again, we can use the fault tree to verify that we're meeting our probability requirements. Now, that's one of the new features, is setting these requirements in the for the ASIL rankings. One of the other new features that we had for aerospace for the DAL verifications, but now we've added for the fault tree, is the ASIL verification as well, and that can look at our cut sets, because with the decompositions, there's requirements in the 26262 standard for what combinations of faults are allowed when you're looking at the contributions. So, and here's where it links back to the fault tree. Each event in the fault tree can be ranked. We've added a new tab for DAL or ASIL. Can be ranked from QM to level D for each event. Then, when I run the analysis and give it a few seconds, it's going to take my computer a few seconds to to calculate the cut sets, essentially what we can do is we can compare the ASIL rankings of the events, the cut sets of the fault tree, to the requirements set in the system safety assessment module. So I can go to that analysis ASIL verification, choose my requirements, my top level hazard probability. Now again, I haven't set the component ASILs for everything. So it will show me all the cut sets, right? And then all the component ASILs. No, there's the one I did set. I set that was ASIL D. So it's combined ASIL is level D. So it's meeting its requirements. So essentially it's going to show us the combined ASILs of the cut sets, how it compares to the requirements. So I set this as ASIL D. And so if it doesn't meet it, so all these others are QM because I didn't set anything for the basic events, it highlights it in orange. If it does meet it, it lets it go in white. So we can compare to make sure that our cut sets, our combinations, our component failure combinations are meeting the ASIL requirements for whatever system hazard that we have. Okay. Make sense, Clint? Any questions on that?
No, this is great. I do have a couple other questions, but I'll retain those until you're done with your presentation.
Well, I'm basically done with my part, so unless there's
okay,
we can go to your general questions now.
So one of the questions, or maybe not questions, but can you perhaps, I know this is maybe a little off topic, but can you describe or show how these different modules would interface with an integration like doors or something like that?
Sure. So for doors, so the safety assessment module has overlap with doors, right, for their functions. Doors is used for requirements tracking and verification as well. So we've integrated in some of that in the safety assessment module. But if you do have doors and you're using doors for your requirements verification, then we have our data link manager. I don't have that open, so we have a separate utility, Isograph data link manager. Give me a second to pop it open. That can link reliability workbench objects to a doors object. So I can create link sets between a reliability workbench object and a doors object. In doors, there's a function to grab the URL for any given item, and in reliability workbench, there's an option to do the same. So you can link them together and then transfer once I've created those links. And of course, I don't have a doors database installed on my computer, so unfortunately I can't show it. But once we've done that, we can transfer the data from Reliability Workbench into the Data Link Manager, like the calculated results from Reliability Workbench, and compare it with our doors requirements. So we can do a lot of that same functionality that we have in the safety assessment module of comparing and tracking the requirements verification. So again, I can't show it in doors how we get the URL. I'll just show in Reliability Workbench there's a way of generating a URL for any object. So if I go back to my fault tree and select my top gates under the the tools menu, there's a copy URL to clipboard. And when I do that, go back to my data link manager. I say paste RWB URL. It grabs the URL referring to the file and the object in that file. Okay. What was the other question, Clint?
So the other question I had, I know that you are constantly interacting with groups from automotive and autonomous vehicles and so forth. What would you say is the top one or two things that maybe isn't intuitive in the software that people ask for or are curious about that you've run into? I know this is out of the blue question, but is there maybe like one or two things that you run into on a regular basis where it's not intuitive that the software would support a certain standard or element of the standard?
Wow, that's you're really throwing me a curveball there, Clint. I like your confidence and your faith in me that I can answer that on the fly. Generally speaking, I'd say, and this isn't necessarily just for automotive, but generally speaking, fault tree analysis to a newcomer can seem counterintuitive, just the way it works. So if you've read up in your master on the 26262 standard, it doesn't really talk about the specifics of how you do a fault tree. So when you're used to the calculations as performed in that standard, and now you're trying to move into the fault tree world, it can seem a little different from what you're used to. So people often are looking for a straightforward way of calculating that single point fault metric in the residual faults and the probability metric for hardware faults. And the answer to that general question is you've got to do it the fault tree way, which is, once you understand it, is extremely powerful, but it's just wrapping your head around that brain, or wrapping your brain around that problem. So once you've got that down, and of course Isograph assists with that. We have training for fault tree analysis. We have other videos on our websites about fault tree analysis. Once you've got that under your belt, then it makes a lot more sense.
So most of the roadblocks you run into are related to
the methodology, really. The just learning fault tree analysis. Really,
yeah. And again, yeah, that's the great part, is that we do offer support on the fault tree side, which would be, almost separate from our software package itself, just understanding some of that logic and how to build those out, right?
Right, yeah. Yeah, exactly. Just how to, how do I model? And this is where the Isographs training might come in. I think we have a few webinars on our YouTube channel. We have a few other things that would help you, just get started with how do I do this? How do I build a fault tree for my system? And so that's the hard jumping off point, right?
Yeah, well, I really appreciate the gratuitous plug. It's awesome. But that's been my experience too, is that, a lot of this ISO 26262 discipline, the customers or prospects we interact with run into the challenge of building out some of these fault trees. It seems like that's, really the foundation of what drives a lot of this.
Right, yeah. Yeah, so, the fault tree driving a lot of this. Could you repeat that one more time, Clint? I lost a word or two there.
No, I'm just saying that from my experience, that fault tree tends to be the point of struggle with building out a lot of the safety assessments, make sure they're in harmony with the standard and so forth. So
right, yeah, and if you're in automotive, you're not alone. Everybody has that learning curve. Aerospace, petrochemical, process safety, they all have, because they're all using fault trees to evaluate safety systems, and they all have that same issue of how do I get started turning this schematic that I'm looking at into the fault tree analysis. So there's always a little bit of a learning curve there, and Isograph can always help you out with that. We have the software, we have videos, we have training, we have things to help you get started.
Well, I think those are all of the questions I have for today. Was there any other functionality or things that occur to you that would showcase some of the new functionality of Reliability Workbench 14.01?
Check out the release notes. We can email those to you. They're also available from the customer area of our website. The release notes that contain the features in the new version. It's not a new feature, but I will also mention one other aspect that people like to use with 26262 is they're looking for failure rate prediction. So I'll just point it out, although I'm not going to go into any detail on it. The prediction module, specifically, many people are interested in either IEC TR62380 prediction or SN29500, Siemens SN29500 prediction. Now, of course, that would be a separate little webinar on their own to go over that, but I'll mention those. If you are interested, we do have them, we do support them, and they do, and this is the important part, link to the FAMICA and the fault tree. You can use these to calculate the failure rates you're then going to use in the FAMICA blocks or the fault tree events.
That's perfect. Joe, thank you so much for the presentation today.
Sure, you're welcome.
Again, if you have any questions or would like to take a free demo of our software, please visit isograph.com. Trial is totally free without obligation. There's no credit card required. It's just an opportunity for you to try out our features. We appreciate your attendance today. I've posted right here all of our contact information. If you have any questions, please reach out. We're happy to help in any way we can. Again, thank you for attending and have a wonderful rest of your day.